Let's continue our presentations and our discussions. And today's subject is aircraft operational reliability models. And we will see today short list of distributions, functions, theorems, equations. And we don't see today any operational reliability related tasks, examples, distributions, functions, theorems, formulas. Why we are doing this way? Because I'm planning, I don't know how it goes, but I'm planning to create standalone, separate operational reliability related tasks, formulas, distributions, examples, presentations. And then we are going to see, we're going to discuss how to nicely connect all these items from operational reliability side and from mathematical statistical analysis side, distributions, functions, theorems. However, we're going to have very interesting discussion today. We will try to, let me put this way, identify some filters. I call it precautionary warnings when we are using mathematical and statistical analysis, mathematical statistical tools. So why do we need this? Because, again, from general perspective, we are not talking here something specific, as I mentioned, right? We're going to have a little bit of, I'm planning, as I said, to create standalone presentations, but here we're going to still, we can still identify some general filter, right? To minimize our, when we are using all these distribution functions theorems, right? To minimize mistakes or errors on just ambiguity. And number two, we will see, as already mentioned, short list of mathematical statistical items using in operational reliability, to analyze operational reliability. Now let's start from number one. Excuse me. Operational reliability. Suppose we just issued our reliability report. We publish it, and our reliability review board reviews this report, and what we see bus power control unit, BPCU, removals exceeding alert level, and RRB makes decision to include new task in maintenance program soft time section, BPCU, removals for overhaul. Okay, and what we have to do, we have to also tell our maintenance program interval that we want to overhaul this BPCU. So this is one of the tasks, one of the many right tasks from our operational reliability side. So we have to calculate, we have to set the interval. So how we can calculate interval? There are different ways. Suppose we are tracking on BPCU on-wing removals, flight hours, and let's say we have 20 removals. Okay, and minimum is 200 flight hours. Maximum, just example, 1200 flight hours. First, what we can do, first way, we can just take this minimum number and tell our maintenance program interval is for this new BPCU task 200 flight hours. Another way, what we can do, we can use some tool to support our decision. That's where all our distributions, functions, theorems, equations, formulas are going to help us. We call it mathematical. We're going to do mathematical statistical analysis. Suppose we take these 20 removals, put in these distributions functions, we've got the result is, again, example, 500 flight hours. My question is, can we now take these 500 flight hours and tell maintenance program that actually this is not 200, this is 500 flight hour interval? Answer is no. Why? Because final decision should be based on engineering judgment, which should be based on experience, maintenance, operation, and business requirements and models. We cannot just blindly take these 500 flight hours. It can be 500 flight hours. I'm saying no. But we cannot blindly take these 500 flight hours and tell maintenance program without reviewing all these items, right? Hey, the interval for this new task, BPCU removals overhaul, is 500 flight hours. Now, this is not correct. Why? Let me explain why. Actually, what we are doing when we are taking these 20 removals and inserting in our distribution functions, formulas, theorems, equations, we actually trying to describe our real-life events, our operational events, our practical side, right? Try to describe using some theoretical information, in this case, mathematical numbers. So as a result, we have two sides here. We have one practical side, the real-life side, which is all these 20 removals, and another side we have some theoretical / mathematical models in this particular case, right? And then, unfortunately, they are not always on the same page when we try to analyze, as I put here, our maintenance, in this case, operational reliability task, which was interval calculation, right? We need to calculate interval. They are not always on the same page. Okay? What we can do? Can we bring these two items on the same page? Answer is, again, from general perspective, it is actually depends on. Each case is individual. Each case is unique. Depends on case by case. We cannot just say, hey, do you know what? Yes. Answer is 100% yes, or answer is 100% no. No, it does work this way. So we have to go through case by case, one by one, and define which distribution, which formula, which theorem, which function we have to use to solve the particular problem, particular task. But still, there are some general, I put here, as I said, precautionary warnings. Okay? So we can do, to bring all these two items together, actually it's 3 items, right? We have 3 members here, right? We can do model check. We can put the filter on this model. We can do some, as I said, precautionary, we can go through the precautionary warning items when we build the model. How? Let's now move to the next slide and start from model building. Okay.